Improve Life European project, carried out by the Spanish Research Council, CSIC, and Metropolitan Transport of Barcelona, TMB. Evaluation and improvement of the subway air quality.
The Barcelona Metro Rail subway operator TMB is working together with a scientific research team from the Spanish Research Council on the European-funded Improve Life project. The primary objective of this project is to demonstrate how to improve air quality in subway systems.
The European-funded 3-year Improve Life project involves close collaboration between TMB and the Spanish Research Council. We are aiming at an improvement of the quality of the air we breathe when riding the subway system. In order to do this, we are studying the particles emitted by the moving train from the rail, wheels, brakes and catenary system, and the effect of air conditioning inside the carriage. We are also studying the effect of tunnel nightwork operations such as rail replacement and ballast movement.
Actions to carry out. The Improve Life project aims to analyse the impact that key factors have on the quality of air you breathe in subway stations, especially on the platforms and inside the trains. The factors taken into account are as follows. Types of station and tunnel. Over the 90 years of Barcelona Metro history, different methods of tunnel excavation have been applied. Ranging from Belgian, Austrian and German models to tunnel boring machines, which offer greater security, while continuously digging, supporting and shuttering the tunnel. Within the 156 stations that comprise the TMB subway network, we therefore find various different designs. From the oldest stations of Plaza de Catalunya and Plaza España to the most recently opened station of Plaza de Europa Fira. Types of stations and tunnel. For the purposes of the study, 4 of the most representative configurations have been a single tunnel with 2 rail lines and side platforms. A single tunnel with 2 rail lines separated by a central wall and side platforms. A one-way single-track tunnel with side platform. A one-way single-track tunnel with side platform separated from the track by platform screen doors. It has also been noted whether the tracks run on a bed of ballast or on a concrete base, and the depth below ground level of each station. This varies from 0 to 74 meters. Ventilation in stations. In Improve Life, special attention is being paid to the depth of the stations of the metro network, the characteristics of their ventilation, the impact of the piston effect that the train produces when passing through the tunnel, causing tunnel air suction as the train enters the station, and air pressure increase when it re-enters the tunnel. In the study, we have distinguished 2 types of ventilation. Ventilation in conventional lines. Ventilation in stations of conventional lines where there's no separation between the air in the tunnel and station. At these stations, the air is renewed using ventilation ducts that are distributed along the platform. Depending on the time of year, and therefore ambient temperature, the station fans work at more or less power. ventilation in automatic lines. In these lines, there are glass screens in the platforms. There are two separate ventilation systems for tunnel and station. Fans in the room ventilation on the top floor of the station force air into the main chamber vent, located in the pre-platform, from where the air is conducted to enter the platform below the benches and then be extracted through vents at the top of the platform. In the tunnel, outside air is blown into the two tunnels and extracted back outdoors by a ventilation shaft. This process is repeated from station to station. Air conditioning on trains. An analysis of the air quality inside the moving carriages has been made among the 165 trains that form the fleet of the Barcelona subway. This study has included testing the characteristics of the filtering system in the air conditioning equipment, which creates a cleaner atmosphere inside the carriages, experimenting with the filter change period and evaluating optimum filter effectiveness. Infrastructure materials subject to wear. We have also analysed the impact on air quality of the ballast, dust generation during both replacement night works and during the execution of major works such as rail line removal and renewal. Rail and catenary wear, analysing the presence in the air of particles derived from friction. Train materials suffering friction. This part of the study has focused in particular on particles released by the wheels while in contact with the rail, the pantographs, whether copper or graphite, while in contact with the catenary, the brushes of electric motors, wear of brake pads and brake shoes that act on the brake discs, As the Improve Life project has developed, the investigation team at the Spanish Research Council has applied a protocol. Firstly, to analyse air quality in the platforms of the stations chosen for the various tests. Each measuring station consists of a high-volume sampler to collect atmospheric particulate matter for subsequent chemical analysis, an equipment that simultaneously measures the concentration in air of inhalable atmospheric particles in 3 sizes, an equipment to measure carbon monoxide, carbon dioxide, temperature and relative humidity. Then, CSIC analyses in its laboratories the chemical composition of the materials produced by wear of subway materials to study their contribution to the particles we breathe on the platform of the station. And finally, CSIC is measuring the effectiveness of air purification equipment systems within the subway environment, especially on the platform. The objective of the Improve Life project is to evaluate air quality in the rail subway facilities and propose measures to achieve a better and purer breathing environment underground, for the benefit of all commuters and workers using the subway network.